This is mathheals.com, where you can find more links to YouTube videos for math and computer science. Let's take a look at the parabola. Now these are the formulas we're going to be using, and I'll flip back and forth to this slide here because we'll use this a lot of times. These are our different standard forms. We've got two different forms. X minus h, all of it squared, is equal to 4p times y minus k. And y minus k, all of it squared, is equal to 4p times x minus h. A difference between these two formulas: the top one, the square root is on the x; the bottom one, the square root is on the y. So it's very easy to tell them apart. Our vertex on both of them, actually, is hk. Now our top formula, focus, is h, comma, k plus p. And those letters come from your standard form. And your directrix is y is equal to k minus p. Now on the bottom, of course, we already said about a vertex, but focus is h plus p, comma, k. And directrix is x equals h minus p. Now I don't never really write down definition of focus and directrix. I dive right in, showing an example, and once you see it with an example, that's just will beat any kind of words that could ever try to describe it. So let's look at our first example here. We've got x squared is equal to negative 8x. Okay. Square root is on the x, square root is on the x. That's the top formula. So we're going to try to get it to look like this. So over on the left side, we need x minus or x plus a number. I'm going to choose minus. And you think, what number can I put here such that it won't change its original value? Well, if I put 0 in there, x minus 0 is x, and x to the second power gives us our x squared. And I have a typo on this. I need to actually correct that. That should be a y. And over on the other side, we need a parentheses before the y. Well, easy way to create a parentheses before the y is just factor out the number that's in front of your y, like that. Okay, well, the number out in front, we want to rewrite it as 4 times something. So I need to rewrite that as 4 times something. And we need this as y plus or y minus a number. And this is the same little trick as the other one. If you just have a single variable there, it's always just y minus or x minus 0. Now the negative 8, we can rewrite that as 4 times negative 2. Now this is in our standard form now. So our h is what's before our x. So this is h, and it's always going to be opposite sign. Now 0 doesn't have a sign, so that doesn't matter in this case. And from our formula, the k is what goes with our y. And it's also going to be opposite sign. Now k is just going to be equal to 0 because 0 doesn't have a sign. So, and this is our p. 4 times p. And this is going to be the same sign. So whatever sign it was, it stays. So p is equal to negative 2. If you're wondering why is it opposite sign, whenever you have a minus in your formula like this, that always will flip signs. Okay. Now from our formula, vertex is hk, right here. H we said was 0, k we said was 0. Our focus was hk plus p from this formula. Well, h was 0, k was 0, plus p, which is negative 2. So this will be 0, negative 2. Our directrix is y is equal to k minus p. K is 0 minus p, which was negative 2. So we got negative, negative, and that gives us a positive, so we got y is equal to 2. So that would be our vertex, focus, and directrix, which is what they're not specifically asking for that in this problem. They just say graph it. But in order to graph this, you have to have those pieces of information. Okay, vertex is 0, 0. So it's right here in the middle. Focus is 0, negative 2. So that'd be down there. Directrix is y is equal to 2. So that y is equal to 2 is a horizontal line at 2. Okay, so this is our focus, this is our directrix. We're going to pick a point, we're going to plot points basically. Look where my point is right here. Look at the distance from my point to the directrix and my distance from the point to the focus. They have to be the same. Obviously they're not. So let me scoot my point out a little bit. Maybe about right there. Now look at the distance between my point and the directrix and point and the focus. It looks about the same, doesn't it? If I were to go straight up from here, and say that distance is 3. Then if I go over to the distance to the focus, that distance should also be 3. And it should form a 90-degree angle when you go to the directrix. Now it doesn't matter where you put your point at. You just come down, you start looking, like I put it right here. Now I'm eyeballing the distance from this to the directrix and this to the focus, and it looks like I need to go out a little bit. Maybe right there. I'm guessing. I'm not very good at eyeballing these. Again, we're looking at distance from the to the directrix. Let's say that distance is 4. Then that distance from that point to the focus should also be 4. Now once you get enough to see your curve, then you go ahead and then draw a parabola. We know what a parabola looks like mostly. And then this over here will be, it's symmetric, so we'll just draw this over here like this. And that'd be our graph. So again, the directrix and focus help us come up with the graph. Any point on this should be equal distance from the focus and to the directrix. We'll look at another one of those. Okay, let's graph this one. We got y plus 2 squared equals 4 times x minus 2. Now the square root is on the y, so we come down here, square root is on the y. We want to use the bottom formula. Now we want to rewrite this as y plus a number or y minus a number. And that's good. This should be x plus a number or x minus a number, and that's good. The only thing that's off is this right here in front, so let's rewrite it. We want to rewrite it as 4 times a number. Well, originally it was 4, so you ask yourself what times 4 gives you 4, and that'd be 1. So from our formula, this is going to be k, and it's going to be opposite sign, so it'll be negative 2, right here. This is our h, and it's going to be opposite sign, so it'll be a positive 2. And this is going to be our p, and it'll be the same sign it was, so it'll stay 1, a positive 1. Our vertex is hk, which is negative 2. Let's try it again. H is 2. And then k is negative 2. And our focus is h plus p comma k. H was 2, p is 1, comma k, which was negative 2. So we're going to have 3, negative 2. And our directrix is x equals h minus p. Okay, h is 2 minus p, which was 1. So we got x is equal to 1. Okay, let's graph this. Our vertex is 2, negative 2. So 2, negative 2, that's our vertex. Our focus is 3, negative 2. and our directrix is x equals 1. And I'll put dash line here. That's our directrix. Now what you're going to find is the focus will be exactly in the middle of the directrix in the focus. So this vertex here I see is a distance of 1 over to the directrix and distance of 1 to the focus. So then I know that's right. Over here, here's our vertex, here's our focus. There's distance of 2 there, distance 2 to the directrix. That's kind of a quick check you can do to see if you did them right. I did one the other day in Calc 2, and I messed up some basic math, and it wasn't that relationship. So I knew I had screwed up my basic math, so I went back and found my error. Okay, we're going to pick a point. I come out here, let's say I pick this point right here. See where my point is compared to the directrix? If I look at the distance from my point to the directrix, distance to focus are not the same. So I keep moving this point out until they look roughly the same. Yeah, that's probably as good as I'm going to get. Now again, what I'm doing is looking at this distance here, say that's 2, and then this distance here, well, should also be 2. Okay, I'll come out here, trying to eyeball the distance between this point and the focus and the directrix. That's good, I think. Again, if I look at that distance to the focus, let's say that distance is 3, then this distance right here, forming a 90 degrees, should also be 3. Looks like I'm maybe a little bit off there, but we'll go with it. Okay, now once you get enough to see your curve, then you go ahead and sketch it. One more point would probably have been more appropriate, but boy, that side was real bad. Let me try that again. Okay. That's probably as good as I'm going to do by hand. Okay, this is the parabola. Let me save that page. And let's look at our next problem. Number 3. It says find the equation of the parabola described and graph it. So we got our focus, which is 0, 5, and our vertex, excuse me, 0, 0. I'm going to grab a drink here real quick. Well, unfortunately, the top formula and the bottom formula both have vertexes and focus, so that doesn't help us any. It doesn't tell us which one to use. Notice this top formula here. See how the x part of the vertex and the x part of the focus, they're both h, aren't they? That means that the x part is the same. Now down here in this one, the vertex and focus, notice the y part are both k. That means the y parts are the same. Well, if I look at this here, I got the x part here and the x part here are the same. So if I come over here, I'm going to use this top formula because the x parts of the vertex and focus are the same. So top formula. And that's probably a bad place to put that, but let me erase that. That's our top formula. Okay, so our top formula says the focus is h, comma, k plus p. So that means this is h, so h is 0. And this is k plus p, so k plus p is 5. Now our vertex is hk. So that says this is h is 0, and that says this is k, so k is equal to 0. Now in order to find all the different things we need the 3 variables. We need h, k, and p. So that's kind of your guide here is to find those. Well, we got h, we got k, we don't have p though. But in this formula here, k k plus p is equal to 5. Over here we said k is 0. So we'll put 0 in for the k. So we've got 0 plus p is equal to 5, or p is equal to 5. So that gives us our 3 items. Now specifically instructions say find the equation of the parabola, describe and graph it. So we don't have to actually write down what the directrix is and so forth. Now it's sometimes handy to in order to graph it to get that information. Now we said we're dealing with our top formula. Top formula looks like this. X minus h squared is equal to 4p times y minus k. So we got h is 0, so we got x minus 0 squared is equal to 4 times p, which is 5, times y minus k, so y minus 0. Well, x minus 0 is x, so we got x squared is equal to 4 times 5 is 20, and y minus 0 is y. That's our equation. Okay. Now it was beneficial to get our directrix. We got our focus, we got our vertex. So let's go ahead and find our directrix. Top formula, y is equal to k minus p. Well, k is 0 minus p, which is 5. So we got y is equal to negative 5. Okay. So our vertex is 0, 0. Right there. Our focus is 0, 5. That should be right there. And our directrix is y is equal to negative 5. So that's our directrix. Okay. So we're going to plot points. And again, I'm looking here. I'm trying to eyeball the distance between my point and the directrix and point and the focus. That looks like might be good. Maybe right there. So then got that, and then we go out this way, and that gives us that. As good as I can freehand it. Okay, number 4. Vertex is 5, negative 1. And our focus is 8, negative 1. Okay. Notice the y parts are the same, aren't they? They're both negative 1. So if I come here, our y part's the same as the bottom formula. See how the k? So y parts are the same. So we're going to use the bottom formula in this. For the bottom formula, of course, vertex is always hk, so that's nothing surprising there. So h is 5, and k is equal to negative 1. Now our focus, h plus p, comma k. So this is h plus p, so h plus p is equal to 8, and k is equal to negative 1, though we already wrote that down here. Okay, remember the 3 things we need. We need h, k, and p. Well, here's p, and I know what h is. Over here we said it's 5, so I can put 5 in for the h, plus p equals 8. Take the 5 over, becomes a negative 5, and we get p is equal to 3. So we got h is 5, k is negative 1, and p is 3. Our bottom formula says y minus k squared is equal to 4p x minus h. So we've got y minus k was negative 1. 4 times p was 3. And x minus h, and h is 5. So this becomes y plus 1 squared is equal to 4 times 3, which is 12, times x minus 5. Okay, now I'm going to get the directrix to help me actually graph this. For our bottom formula, it's x equals h minus p. H is 5 minus p, which was 3. So we got x equals 2. Okay. Vertex is 5, negative 1. 3, 4, 5, negative 1. So that's our vertex. And focus is 8, negative 1. 6, 7, 8, negative 1. Then our directrix is x equals 2. Okay, now pick a point here. I'm trying to eyeball the distance between my directrix and this point in the focus, and they should be the same. That looks not too bad. Maybe right there. Again, I'm looking at these distances. So then I'll graph them. And by symmetry, this one also looks like that. Let's save this page. Time for it to blow up. There we go. Let's take a look at number 5. It says focus is negative 2, 3. And our directrix is y is equal to negative 5. Now these are slightly easier. You notice our directrix up here is y equals something. Directrix down here is x equals something. So by telling us that directrix is y equals something, that tells us this is top formula. So this is our top formula we're looking at. Now our focus is h and then k plus p. That means this is h, so h is negative 2. And this is k plus p, so k plus p is equal to 3. Learn to speak someday. Directrix, y equals k minus p. That means that this is k minus p. So k minus p is equal to negative 5. Now the h is already there for us, but the other two, we've got a system of equations. We can use the addition method on them, the elimination method, such that if we add them together, k plus k is 2k, p minus p drops away, 3 minus 5 is negative 2. Then we've got 2k is equal to negative 2. We divide both sides by 2. And we get k is equal to negative 1. Okay, so we got h, we got k. So h is negative 2, k is negative 1. Now we need to find p. So I'll take this negative 1 and I'll plug it back into one of these equations. Doesn't matter which one. The k plus p is equal to 3 looks easier. So k is negative 1 plus p is equal to 3. Take negative 1 over and I get 3 plus 1, or p is equal to 4. Okay. Now we started dealing with the top formula. So we got x minus h squared is equal to 4p y minus k. Okay, so we got x minus h, which was negative 2 squared, equals 4 times p. P was 4. And y minus k, and k is negative 1. So negative negative becomes positive here, so we got x plus 2 squared. 4 times 4 is 16, and negative negative there gives me a positive, so we got y plus 1. And this would be our answer. Now I want to graph it. So let me come over here. Well, actually, do we have everything? Focus, directrix. We don't have a vertex, do we? So let me write down the vertex. Vertex is always HK. H was -2, comma, K was -1. Okay, so vertex is -2, -1. Our focus is -2, 3. Right there. And our directrix is y is equal to -5. Again, a very quick check is the distance between the vertex and directrix should be the same as the distance between the vertex and the focus. And it is, so that's good. Okay, I come over here, I'm eyeballing distances again. Maybe right there. Again, what we're doing, distance here to the focus, let's say that's 5. That should match the distance here to the directrix, forming a 90-degree angle. Doesn't look like I got it quite right, but we'll go with it. I'm not very good at eyeballing these. Maybe right there. Okay. So we got that side, then by symmetry this side will be should be symmetric. Good enough. We're just sketching. Okay, next problem. Grab a drink actually first. This is asking us to identify the vertex, focus, and directrix and graph it. So we had to put them in standard form. This is not much different than the first ones we did. And then they'll progressively get harder. So let's go back up to our formulas. Square root is on the y. So we look for this bottom formula, square root is on the y. We're going to use this one. We want it to look like our standard form here. So I'm going to rewrite this as y minus some number squared. And again, remember if you have a single letter, you just put 0. Over on this side, we need parentheses before the x. So I'll factor out a -8. You can always create a parentheses before the x by factoring out the number that's in front of it. Now we want to rewrite that -8 as 4 times something, and that'd be -2. And we want this to be x plus or minus a number, and we're going to put x minus 0 in there. Okay, this is our k, and it's opposite sign, but 0 is just 0. And this is our h, and it's going to be opposite sign, which is just 0. And this is going to be p, and it's going to be our same sign, which is -2. Now we said we're using the bottom formula. So the bottom. So our vertex is hk. Which is 0, 0. Our focus is h plus p comma k. So h plus p comma k. Well, h we said was 0 plus p, which is -2, comma k, which is 0. So we're going to have -2, 0. And our directrix is x equals h minus p. So h is 0 minus p was -2. So we got negative, which gives us a +2. Those are our vertex, focus, and directrix. So to graph it, our vertex would be 0, 0. Focus is -2, 0. And our directrix, or focus, is -2, 0, and directrix is x equals 2. Okay, so I'm going to come over here and maybe right there. Come over here. Maybe right there. Again, I'm eyeballing the distance between this and the focus, and this distance from this to the directrix, and they should be the same. So there's that part of the graph. And by symmetry, this comes down here, looks like that. And those are answers. And there's my vertex, focus, and directrix, and then our graph. Let's save that. And gets ready for number 7. So we've got y plus 3 squared equals negative 8 times x minus 1. Okay. Same instructions. Squared is on the y. Squared is on the y. We want the bottom formula again. Now this is almost in perfect form. We want this as y plus or y minus a number, so that's fine. We'll write this as 4 times negative 2. And we want that to be x plus or minus a number. So this is k, and it's going to be opposite signs, so it'll be negative 3. K always goes with your y, and h always goes with your x. Doesn't matter how if they're flipped around. And h is opposite sign, which is positive 1. And our p will be negative 2. Now our vertex is always hk. So it'll be 1, negative 3 for a vertex. Now our focus is h plus p comma k. So we've got h, which is 1, and plus p, which is negative 2, comma k, which is negative 3. 1 minus 2 is negative 1, negative 3. Our directrix is the x equals h minus p. H was 1 minus p, which is negative 2. So we got negative negative, which becomes positive, so we got x is equal to 3. Well, let's use those to get the graph. Okay, our vertex is 1, negative 3. Our focus is negative 1, negative 3. And our directrix is x equals 3. Okay, now I'm going to eyeball points here. Maybe one right there. And maybe one right here. Again, I'm eyeballing distance from a point to the focus and distance from that point to a directrix. It should be the same. And I'm just adjusting it accordingly. Now you're getting tired of hearing that, but just in case there's a few that still aren't getting that, then by symmetry, then you come up with that. Okay, number 8. We got x minus 1 squared equals negative y plus 2. I think next ones are completing a square, which are different. Okay, squared is on the x, squared is on the x. We want top formula. Now this is almost in good shape. Got x minus 1 squared equals 4 times something, and y plus or minus the number. Well, if you can't think what number should be here, like this is a negative 1. Remember the invisible 1? If you can't think what times 4 gives you a negative 1, Well, take whatever number you have here, in this case a -1, put it up on top, and we put 4 down below. Not always works that way. Whatever numbers are here, you can put up on top, and then always put 4 here. Like this is 17. And you try to think, okay, what times 4 gives you 17? Put 17 here, put 4 here. Well, this is going to be our h. It's opposite sign, which is 1. And this is k, and its opposite sign, which is -2. And this is p, and it's going to be the same sign it was, which was -1/4. And our vertex is hk, which will be 1, -2. Our focus is hk plus p. H was 1, k is -2, plus p, so -1/4. That gives us -9/4. I took -2 times 4 gives you -8, and I added -1, and that gives us a -9. Then the denominator stays the same. It's just a mixed number. And then our directrix is y is equal to k minus p. Well, k was -2 minus p, which was -1/4. That gives us -2 plus 1/4. This is a mixed number. I'll take -2 times 4 gives us -8, and add to 1. That gives us -7/4. So y is equal to -7/4. Okay, vertex is 1, -2. So 1, -2, that's my vertex. Focus is 1, -9/4. That's -2 1/4. So 1 and -2 1/4. Let's try this all again. Okay, 1, -2. So 1, -2. It's right there. That's my vertex. Focus is 1 and -2 1/4. That's still, I really blow it up to get it, but I don't got room to do that. And this is -1 3/4. That should be something like that. To have these so close together, the graph may not be exactly precise, but it's good enough. It was just sketching anyway. Okay, come over here, look for a distance to be the same from our focus to our directrix. That's probably not too bad. Not great, but I'm not very good at eyeballing distances. Let's say maybe that. Get down to here. I don't think I've done that very well, but oh well. We'll make our points a little bit bigger. There we go. And then I'll sketch it over here too. This is, when we say sketch, we're not looking for precision. Usually you want to come up with something that gives you an idea of what you're working with, so you can then decide what you're trying to find, or how you should approach a problem. If we want any kind of precision, we'll use a computer program. Okay, what problem is that? That was number 8. So we're ready for number 9. Okay, so we got x squared plus 8x minus 4y plus 28 equals 0. Same instructions as before. Find the vertex, focus, directrix, graph it, so forth. square root is on the x, square root is on the x. We want the top formula. Now we're going to have to use complete in the square to get it in this form. Let me write my steps over here. Steps to write in standard form. Okay. Step 1. Get all the variables. With the squared part. On one side. Everything else on the other side. Everything else, boy, that's... If you can read my writing, it'd be a miracle. Everything else on the other side. What do I mean by that? Get all the variables with squared part. I never have been able to put this in words. I really like it. The squared is on the x, so we're going to get everything with x on one side. Now the next problem, that may change because the squared may be on the y. And we'll take the rest of it over to the right side. Remember, when you take anything over, the sign changes. So negative 4y becomes a positive 4y, and positive 28 becomes a negative 28. Now we're going to complete the square. On the squared part. So complete the square and the squared part. Well, the part that's squared is our x, so we're going to complete the square on it. Remember, in completing the square, you take the numbers before your x, which is 8, and you always multiply it by half, and you always square it. Well, 8 times a half is 4, and 4 squared gives us 16. And then we're going to add that to both sides. So we got x squared plus 8x plus 16 equals 4y minus 28 plus 16. Now remember, in completing a square, you need to factor this side now. This factors as x plus 4 squared. And over here, negative 28 plus 16 gives us negative 12. Like that. Remember the little trick for that. When you factor this, whatever number is in your parentheses right before you square it, this right here, sign included is what goes right here always. Well, this is starting to look like standard form. We got the top formula, so x plus or minus the number squared. Well, that works. The right side needs a little bit more work. We'll factor out the number in front of the variable. So we got x plus 4 squared, and then we factor out the 4, and that gives us y minus 3. Because remember what we want. We want a parentheses before the y, don't we? So you always factor that number out. And now, this is in our standard form. And a little bit of rewriting. We got x plus 4 squared is equal, want to rewrite that as 4 times something. Well, 4 is 4 times 1. So now we can identify our various items. Number with your x is h. It's all opposite signs. So we got h is negative 4. This is p. It's same sign, so p is 1. And this is k, and it's opposite sign, so k will be 3. Now our vertex will be hk, which is negative 4, 3. Our focus, and let's see, we're using top formula, aren't we? Is h k plus p. Well, h is -4, k is 3, and p is 1. Then I got -4, 3 plus 1, which gives us 4. And our directrix is y is equal to k minus p. K is 3 minus p, which is 1. So we got y is equal to 2. Okay, let's see what we get. Vertex is -4, 3. Focus is -4, 4. And directrix is y is equal to 2. Okay, so I'll pick points. Maybe right there. Maybe right there. Get that. So then by symmetry we get the other side. And I don't think I have room for another one there, so let me save that. Let's look at number 10. Okay, so we got y squared minus 6y minus 8x plus 1 equals 0. Okay, the part that has a squared part on is the y, so we want to get everything with y on one side, everything else over on the other. So I'll take the -8x over, it becomes a positive 8x, take the 1 over, it becomes a -1. Complete square on the y's, so we'll take the number before our y, which is -6, multiply it by half and square it. -6 times a half is -3, and -3 squared is 9. And we'll add that to both sides. Now this factors as y minus 3 squared, and -1 plus 9 gives us 8. Again, remember the trick. Whatever number's right here, right before you square it, is always what goes right here. Okay, so then we got y minus 3 squared, and we have to have for parentheses before our x, so we'll factor out an 8. And that gives us x plus 1. And this is in standard form. I have to do a little bit of rewriting with it. 8 we rewrite as 4 times 2. Now this is the bottom formula. Squared is on the y. Squared is on the y. So this is going to be k, and it's going to be opposite sign, which will be 3. This will be h, and it'll be opposite sign, which is -1. And this will be p, and it'll be the same sign, which is 2. Our vertex is hk, which is -1, 3. Our focus is h plus pk. H was -1 plus p, which is 2, comma k, which is 3. So that gives us 1, 3. And our directrix, bottom formula, x equals h minus p. H is -1 minus p, which is 2. So we got x is equal to -3. Let's see, -1, 3. that'd be our vertex. Focus is 1, 3, which is right there. And directrix is x equals -3, which is right there. I'll plot points, looking for them equal distance from the focus to the directrix. That probably is good enough. Let's see down here though. There we go. And then by symmetry, I'll have that. Okay, I probably don't have room for the next one, so let me save this. And then we'll look at our last problem. Okay, so we got y squared plus 4y equals -x plus 7. Same instructions. And the squared part is on the y. Everything with y is on the left side already, and everything else is on the right side, so that's perfect. We'll complete the square, so take number 4, our y, which is 4, multiply by half and square it. 4 times a half is 2, 2 squared is 4. And then we'll add that to both sides. So we've got y squared plus 4y plus 4 equals -x plus 7 plus 4. Now this factors as y plus 2 squared. Remember the trick for that. Whatever number's right here, sign included, goes right here. And 7 plus 4 is 11. Now this is good on the left side, but on the right side, remember we need parentheses before our x. So I'll factor out -1. And that gives us x minus 11. That's basically standard form, but we will rewrite the -1. And again, you want to rewrite it as 4 times something, and that's not always easy to see when it's a weird number like that. But whatever number's here, you put up on top, and you always put 4 down below. Because going backwards, the 4's would cancel and just give you that. So if this was 7, for example, you'd have 7 over 4. Okay. This is our k, which would be -2. It's opposite sign. This is our h, and it'd be 11. And this is our p, which would be -1/4. Now the squared is on the y. Which one formula is that? Bottom one. Vertex is hk. H is 11. K is -2. Our focus is h plus p k. H is 11. P is -1/4, comma k, which is -2. Now, in truth, I'm going to put this in fraction form, but in truth, the mixed number might be better. 11 times 4 is 44, minus 1 is 43, so 43/4. Like I said, you look at that, it's like, well, where in the world's that at? But 10 and 3/4 is maybe a little easier to see. Sometimes for practical purposes, come up with a mixed number or decimal is actually easier than a fraction. Our directrix. Bottom formula, x equals h minus p. Okay, h is, what is h? 11 minus p, which is -1/4, which gives us 11 plus 1/4, which is 11 1/4. I'm going to put it into fraction form, but again, that's going to be easier to work with right there. And 11 times 4 is 44, plus 1 is 45. So we got 45 fourths. Okay, vertex is 11 and negative 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and negative 2. Focus is 10 3/4. That's 11, 10 3/4, negative 2. Boy, that's almost right on top of it. Sometimes when I make the numbers up, they do this. They don't come out really nice for graphing purposes. 11 1/4 would be on this side like that. Okay, so if I'm plot points right there, and let's say right there, that one would look like this, and then this one, by symmetry, would look like that. So let me save that. And that was our last problem. So let me go ahead and stop the recorders.